In this segment, I'm going to deal with the basics of electricity. I think it's easiest to think of electricity in analogy to a river or a creek. A fundamental quantity in a river is how much current is flowing. In other words, how much water is passing a point in a second. With electricity, current is also really important, but now we're talking about charge that passes a point in a second, not water. We measure that charge passing a point in a second in coulombs. So the current, which is given the symbol I, should be measured in the number of coulombs that pass a point in a second. Just like in the river, we might measure the amount of water that's flowing past a point in the number of buckets of water that are passing a point in a second, say 15 buckets a second. In a wire, we'll count the number of coulombs that go past a point, and that is the value of current, say 3 coulombs per second. A coulomb per second is given a special name. That name is an amp. But you must never forget that what an amp means is it means a coulomb passing a point in a second. So if there's a current of 5 amps flowing, that means 5 coulombs are passing a point in 1 second. Current is the easy part of electricity because I think it's not too difficult to think of the number of coulombs that are passing a point in a second. Voltage is a little bit trickier. Voltage or potential difference. I think the best way to think about that is to think about a lake. If we had a lake, there would be no current flowing. Why is that? The reason is because the bottom of the lake is flat. If you were to pick up one side of the lake and lift it up a little bit, then the water would start flowing down towards the other side. What you've done is you've created a difference in potential, gravitational potential energy. The side that you've lifted up now has more gravitational potential energy than the other side. So the water will rush down from higher potential to lower potential. In electricity, it's a very similar thing. The way we make current flow is we produce a potential difference in the wire. Not a gravitational potential difference, though, this time, an electrical potential difference. The way we can do that is with a battery. With a battery, that's like picking up one side of the wire and putting it at a higher electrical potential than the other side of the wire, the other end. So electrons will tend to flow from the higher potential down to the lower potential. And the greater potential we apply, the more the electrons will flow, the greater the current will get. In a very similar way to the river. The greater the difference in height in the river, the more the current will flow. So why do we use the word potential? What does that mean? The word potential refers to the potential to do work. The potential to do work is given in units of joules per coulomb. That is the energy per unit charge. But 1 joule per coulomb is given another name. It's called a volt. But you must remember, if someone tells you that there is a potential difference across a wire of 10 volts, that means that 1 coulomb of charge at the higher potential end can do 10 joules of work on its way down to the lower potential end. Or it can do 10 joules of work more than the charge, 1 coulomb of charge, at the lower potential end. So let's think about this as an example with a 1.5 volt AA battery, a standard battery. What does that mean, that it's a 1.5 volt battery? Well, it means that if 1 coulomb of charge came out of one side, it could do 1.5 joules of work before re-entering the other side of the battery. So if you connected the battery up to a little light bulb, each coulomb that came out of the top of the battery and went through the light bulb would give off 1.5 joules of light and heat before it re-entered in the other side. So, to summarize, there are 2 fundamental quantities in electricity, current and voltage. Current is the easier one. It's just the number of coulombs that are passing a point in a second. It's given the letter I, the symbol I, and its units are amps. But don't forget, 1 amp just means a coulomb per second. Voltage is a little bit trickier, refers to the difference in potential to do work in a wire. difference in electric potential. It's measured in the number of joules per each coulomb, but that is given the special name, the volt. The greater the amount of voltage that is applied across a wire, the greater the current that will flow in that wire.